Okay, so let's work on this. Now, I think actually we already did this problem. Yep, we did. So, on to the next one. Consider this problem. Okay, so remember, just kind of a review from yesterday, we're talking about limiting reactants. And a limiting reactant, remember, is the one that runs out first in the chemical reaction and it stops the reaction. Okay, just like the s'mores, the graham crackers ran out first, so that stopped the making of the s'mores. All right? So this is going to distract me. I'm going to have to take this down for now. Sorry, I'll put it back. Okay, so here's the next problem after the one that we just worked. Water is produced during the synthesis of hydrogen and oxygen gas. Determine the limiting and excess reactant and exactly how much water can be produced when 1.25 grams of oxygen is mixed with 0.525 grams of hydrogen. Okay, so stoichiometry problem. What's the first thing we always need in a stoichiometry problem? Do you have the equation on your sheet?
Yeah.
Okay, it would have been fun to, well, fun. I think it would have been fun for us to try and figure that out, but just to remind us what synthesis is, remember synthesis is just two things coming together to form one compound at the end. It's a love story, it's a relationship, right? So there's your balanced chemical equation, all right? And what is your, okay, let's pretend that they didn't tell us this limiting and excess reactant part, okay? Let's say that the only thing this said was determine how much water can be produced when 1.25 grams of oxygen is mixed with 0.525 grams of hydrogen. How would you know that's a limiting reactant problem? Okay, not just that there's two numbers necessarily, but what are the two numbers? They're the reactant numbers, right? Okay? They are telling you the amounts of both of your reactants. If they tell you the amounts of both your reactants, or even just two of your reactants if there's more than two, that's a limiting reactant problem because you have to figure out which one of those numbers you're going to use, right? Do you guys remember how we do this? What's our strategy here? You can kind of figure it out as two separate problems, right? So you start with the 1.25 grams of oxygen, figure out how much water could be made from the oxygen. Then you do the same thing with the hydrogen, figure out how much water can be made from the hydrogen, and then you compare those two numbers at the end. The one that makes the least water is your limiting reactant, okay? All right, so let's just go ahead and work. What's that? Oxidized, it means combined. Oh, excess, I thought you said oxidized. Excess means, that's like in our s'mores example, that was the marshmallows and the chocolate. We had extra at the end. We have some left over. Okay, yep. Well, actually, you weren't here yesterday, so I guess you weren't here when we were talking about the s'mores example. But. Okay, so 1.25 grams of oxygen, O2, all right, and we're trying to figure out how much water can be produced. It says exactly how much water can be produced. Okay, now I know I already told you in a previous slide that the limiting reactant problems are usually gram to gram, but I didn't specify here that you had to calculate this in grams, so I guess if you calculated this in moles, I wouldn't be able to count it wrong. And that would save you a step. But we're going to go all the way to grams, okay, because that's the way we usually do these limiting reactant problems. All right, so grams of O2, we're going to go to moles of O2, right? I'm not stopping to quiz you every time now because I think we're getting this process. It's pretty much the same every time. So 1 mole and see, this is where I want to be lazy and just put 32 right there. But I know, I think it's 31.998, right? Oh, come on. There we go. Okay. Pew, pew. I'm not going to do that anymore either, if you don't mind, because it just takes too much time for me to decide what noise I'm going to make. All right, so then I'm going to go from moles of O2 to moles of what? H2O, moles of water. And what's the mole ratio? 2 to 1, based on the balanced chemical equation right here, okay? Then we're going to go from moles of H2O back to grams of H2O. And this is 18.0148, a number that I sadly have memorized. All right, so then we'll just work our way through this 1.25 divided by 31.998 times 2 times 18.0148. Getting 1 point and then a long number after that. How many sig figs do we need in our answer here? 3. Okay, so 1.41.
Wait, so why are we going to grams?
You'll see in just a minute, okay? All right, so then same thing here, 0.525 grams of hydrogen. Now, just looking at, this can be dangerous as well. I haven't pointed this out yet, but just looking at those two amounts, which one would you think maybe is the limiting reactant just by looking at those two amounts? Maybe the hydrogen, right? Kind of makes sense, right? There's less mass of hydrogen. Well, the problem is it all depends on the molar mass of the things you're looking at, and it depends on the ratio in the equation. So we can't just assume, because we see this, we can't assume that that the one with the lowest mass is going to be the limiting reactant. So we have to work it all the way through. All right? So let's see if it keep happening. Come on. Okay. So then we've got grams of H2. We're going to moles of H2. We're going to do the exact same thing here as we did on the other one. H2 is 1.0079. Two of those at 2.0158. Whoops. In 1 mole. We're going to go from moles of H2 to moles of H2O, just like we did before. This time it's a 2 to 2 or a 1 to 1. I don't care how you write that. It's the same. Going to give you the same result. And then moles of H2O back to grams of H2O. And that one's 18.0148 again. All right. So then let's work this out. Oh, look at that. 4.69 is what I'm getting here. So our prediction was wrong, wasn't it? Because we thought the hydrogen would be the limiting reactant just looking at the mass of it. But when we actually worked it out, it can make about 4 times as much of the product as the oxygen can. All right? So we're going to run out of oxygen way before we run out of hydrogen. Does that make sense? So oxygen is the limiting reactant, okay? Okay? Hydrogen is our excess reactant. And I'm okay if you abbreviate those like that. Is everyone okay with that idea? Okay? How I got from these numbers to figuring out which one is limiting, which one's excess. We good? Tell me now if that's confusing you. All right.
Wait, number 2, how much of the excess reactant remains?
Is that part of the same problem, or is that a different one? Okay, so now the question is, whoops, there's my question. Okay, let me erase all this. How much of the excess reactant remains? Now this is a separate calculation that you have to do. Why is that not going away? That 2 should be going away. Okay, now, for this part, oh no, that is what we just did. How much of the excess reactant remains? Okay, now, if we've got this question, let's kind of think about this for a second. Going back to my s'mores example for a second, the way that we would figure this out, if I think I had 50 marshmallows, I think I had 10 graham crackers, and I had 100 chocolate pieces, right? And 4 for each, so we can make 25 with that. So, if I'm asking you, how many marshmallows would I have left over? Or how many chocolate pieces would I have left over? First, we have to figure out how many s'mores I can make total, right? So again, how many s'mores can I make? Okay, well, let's kind of walk everybody through the process here, all right? So I've got 10 graham crackers. I need 2 for each s'more, right? So how many s'mores total can I make? 5. So how many marshmallows would I have left over? Okay, I need, one marshmallow for every s'more, so I'd have 45 left over, right? How many chocolate pieces do I need for each s'more? 4, so I would have to use up 20 for those 5 s'mores, so I would have 80 left. Does that make sense? And that's essentially what this question is asking you, okay? We decided the excess is the hydrogen, okay? How much extra is there? All right? So you could do this one of 2 ways. Actually, there's probably honestly 3 or 4 ways to do this, and I always struggle with what's the best way to do it. Let me think here. Every year, it kind of comes down to me just picking away and going with it. And I'm never quite convinced which way is the best way. Because what you could do is you could work from the oxygen number, right? The mass that we have at the end for oxygen, which is 1.41 grams. Okay? You could figure out, okay, how much hydrogen do I need to make 1.41 grams, right? Which actually, that's a good analogy to the s'mores thing we just talked about. So let's try that, see if this makes sense. If it doesn't, I can show you another way, all right? So we've got 1.41 grams of H2O, right? And that, I figured that out because that's how much can be produced by the oxygen. And as soon as the oxygen runs out, it's going to stop reacting. So that's it. That's all the water that we can make. Okay? Everybody with me? All right. So then what I can do is I can go back to hydrogen now, and I can figure out, okay, how much hydrogen did I need to make that much water? Does that make sense? It's kind of, yeah, it is a lot of steps. But hopefully it makes sense. And that's kind of what we did right here, right? We figured out we can make 5 s'mores. So then I went back and I thought about, all right, how many marshmallows do I need for each s'more? So then, how many would I have left? So I need 5 marshmallows to make that many s'mores, which leaves me with 45, okay? So what we're going to do is figure out how much hydrogen do we need to make this much water, okay? So I'm going to go from grams of H2O, I'm writing this small, back to moles of H2O, and this is 18.0148, and then we're going to go from moles of H2O back to moles of hydrogen, and that's a 2-to-2 ratio. Then we'll go from moles of H2 back to grams. Yeah, 2.0158. I just forgot the number because I erased it. Okay, so then when we work this out, the 1.41 divided by 18.0148, you can do times 2 divided by 2, but that's, you don't have to do that because it's going to cancel out, times the 2.0158. That's going to give you 0.158 when we round, right? Grams of H2. Now, what is that number that I just figured out? See, and this is where it's a little tricky. You got to know what number you're finding. What is that number? There we go. Okay, that's how much hydrogen we used in this reaction, right? Okay, so again, stay with me here. This is where it gets a little tricky, all right? But that's exactly what we did up here. It's just a little less complicated up here, okay? We know we made 5 s'mores, okay? Now you can just kind of look at this and you can tell, oh, okay, well it takes 5 marshmallows to make 5 s'mores, all right? What we just figured out was, okay, it takes 0.158 grams of hydrogen to make 1.41 grams of water, okay? Now how many grams of hydrogen did we have? 0.525, right? That's how much we have. This is how much we needed. You see that? So then how do I figure out how much I have left over? Just subtract the 2, right? That's exactly what we did over here. We subtracted 45 from 50, and that, or sorry, we subtracted 5 from 50, and that gave us 45, okay? So you just take the 1.41, nope. so close to doing this without confusing anybody. You take the 0.525 grams of hydrogen that you initially started with, and then you subtract the 0.158 grams that we used, and that's how much you're going to have left over. I know that's a lot of steps there, but does that make sense? Do you understand why we're doing that? Okay. We'll have another practice here on that. That's the one part that makes this a little bit tricky. What's that? For example, on the worksheet. Oh, are they? Whoops. Okay. So that's the answer to how much remains. Yeah. No. Sorry. Okay, we ready? All right, so then, yeah, once you have identified limiting reactant, you should know that none of this substance remains. How much of the excess reactant is left unused? Okay, I think what's happening here is this is going to take you more step by step through it than I just did. So we can calculate how much of the excess reactant is left once the limiting reactant runs out. And that's what we did. We figured out using the amount of water, right? We figured out how much hydrogen did we need to make that much water, and then we subtracted the two values. Okay. Yeah, and then the example here is the same. Okay, so we just basically skipped ahead a little bit. Did you guys already have all that writing filled in on your notes? You don't have that writing? I mean this part. This part's already filled in for you? Okay. All right, so that's, I mean, I just sort of took you through the process before you saw the words that describe the process, but this is explaining what we did. Okay? I think that's it for limiting reactants. Yeah, because the next part is actual yield and percent yield, so we'll cover that tomorrow. So I've got a worksheet for you guys. You've got actually a good chunk of time right now to work on this. So, and I will print out the answer key for this. I already have the answer key made, so once you work a problem out, you can actually come up and check it. All right? And I'll be walking around in case any of you are confused. So use this time right now because these are not easy problems, and I want to make sure you get this before you take the quiz tomorrow. All right? Okay. Done with the video.